So I think everything is set. I would ask Reinhard to talk. His first topic is key figures for software testing. So I'm pretty looking forward to the talk. It should be around 20 to 25 minutes. I'm looking forward to the talk. So Reinhard, thank you very much for joining today. Let's go.
So, hi everyone, or let's go back. I'm talking about key performance indicator KPIs in the area of testing and testing as a part of software quality. So a short introduction to myself. Well, I'm Reinhard Prehofer. I'm the technical officer of JSparrow, or Splendid, as you might see it. I'm also code certified IT expert, which is a lot of fun to, okay, that's another story. I'm not wasting the 20 minutes on this, but it's quite interesting to see the kind of quality and the reasons why people go to court because of, yeah, they just did not get what they had been asked for, and they had specified different things and so on, and no one understood it. My main topic, and that's my specialization, is software modernization. So that's, I'm dealing with legacy systems. I'm not afraid of them. Might be assembler, COBOL, or whatever, and old systems. But I'm not taking care and maintaining these old systems, but I'm trying together with the customer to renew them, to bring it up into new systems. So sort of as a slogan, COBOL and Java, and not COBOL against Java or vice versa. That's my kind of specialty, and I just love it to do it this way. And if you deal with old coding, also with new coding, of course, you should always have a look at the quality, rather the coding quality, and not so much the kind of other quality. But if you got to maintain coding, which has been written sometimes almost 50 years, and I'm not exaggerating, so more than a sort of lifetime of a programmer ago, you have to take means to assure quality. And that's one of my main topics. So, talking about quality, I always refer to this ISO quality model. And if we have a closer look here at the maintainability sub-area, then we also see, well, it's maybe not so easy to read, but this should read testability, or the sort of correctness. So of course, testing and testability is a quality issue and is specified in that ISO model, but that's more or less all of it what is specified in there. There are no clear hints or clear procedures or clear recommendations of what to do and how this should be done correctly. Thanks, I got a couple of glass of water. So, no. Testing, well, that's sort of, is it expensive? Yes or no? That's always the, I hope I didn't, no. Approximately 20% of software development efforts go into tests. Some say it's up to 30%. But one of the most important things is you cannot start too early with testing. So the biggest problems in the area of testing, if you, as simple as it is, implement the wrong thing. So if you did not do requirements, software engineering and requirements testing sort of. I'm not talking about this now because we will see what kind of tests we are dealing with in software development. And there's a lot of different tools, procedures and methods for that.
I'm sorry, Reinhard. We can't see the slides anymore.
Okay, that's what I had been afraid that something went wrong. Can you see it now again? Thanks for the hint.
Yes. Yes.
Okay, so sorry, I pressed the wrong button, whatever. Okay, I just have to move with the mouse and not with the keyboard arrows. That's what I think. So that's not all types of tests which are around. And if you look for what testing facility or what testing stuff is around, something is still. So you see that the slide now, because that's some strange feedback. I never see the slide which I'm presenting, which is some sort of uneasiness.
Yes,
Oh,
yes,
okay.
We see the slide.
Okay. So if we're talking about tests, and we do have several categories, and if you look into literature, you might find much more different categories. I just split them into sort of functional tests and non-functional tests. The functional tests are more into, of course, the function, what the software is meant to be doing. So is it doing it correctly? Is it doing? And the non-functional tests, if we have a look there, it's more into very important other technical issues, of course, like performance testing and so on, up to compliance, usability testing. That's more with the interfaces for customers, or graphical user interfaces, so the front end to the application. Well, if we're talking about test and testing, does this mean you have to do any of these tests? Well, in an ideal world, and if we have a lot of time, a lot of money and so on, then the answer is yes. Well, my realistic answer is you should at least be aware of that there's a couple of test possibilities around. The good message is there's also a lot of tools around to assist you in there. And then it just depends, simple as it is. If you're talking about performance, is always an issue, of course. But if we are talking about load and stress testing, for example, it depends on the type of application. So if you are writing an in-house application and the number of users is more or less fixed, say around 500, 1000, whatever users, then okay, it's rather easy to find out what are the limits of the hardware you need, memory, and so on and so on. If you're writing an application for the internet and you have no idea at all how many users will try to execute the application simultaneously, then you should have a good look at sort of stress testing so that you can do maybe something like load balancing and so on and so on. This all has, of course, some reverse influence on the kind of how you are implementing your application, but you should be aware of it. The topic I'm addressing much more, and I think also Evelyn is going to that topic, that's more related with the code. So it's a code testing or code unit testing. You are testing the correctness of the code you have written. So it's some sort of simple thing you can, I think you all know it, JUnit and so on. You are testing methods. You know what the expected behavior of a method should be if you provide these and that interfaces or parameters to the method, and you expect a result. So you can program that into a so-called unit test. Arlet will show you a lot about JUnit testing later on. So I'm not even using a sample here because Arlet would laugh about it, because I think I would use JUnit 4 only. So sorry for that. And you just execute it, as simple as it is. And no, not again. So do you see the next KPIs? The next slide, sorry.
Yes, we do. Yeah.
Okay. So I'm not giving real KPIs, but rather more some sort of recommendations of what you do, of what to do. If you're doing something with usability testing, so which in other words says that the application or the user interface is accepted by the user, there's some very, very easy hint or suggestion. Involve the user right from the beginning, absolutely, totally from the beginning, while developing and while designing the user face. And also most important, ask him about test cases. So if you show him the screen, the interface and the input fields and so on, and then the famous, if I press the OK or whatever submit button, what's the expected result? So what's the next screen? What's the next whatever? Ask and collect test cases. That's trivial. That's rather trivial. And the other, I'm talking then more about unit testing and regression testing in the meaning, if you run into an error, prove that the error will be fixed by doing so-called regression testing. So write a test case which takes the input and proves that the former error has been corrected and that the correct result is returned now. I think most of you know that kind of quality gates. That's a screenshot from SonarCube I took in the morning in a project I'm working on. And there you see some sort of quality gates. And well, there's a failed on it because you see a lot of red signs in here. So I commented out what kind of project we are talking about, because that's an external project and the customer would love to see it and so on. But you see some first quality gates, and I'm talking more about the testing stuff now, not the other errors. So the one in this red circle. It's up to you, of course, to define what should be the coverage. So if you execute test code, how many lines of your application should be covered or touched, how many branches should be touched, and so on. And the recommendation is rather high. And I'm not going to discuss that figure if 80% is realistic. Well, this project got some 3.5 million lines of code. So 80% of that is whatever it is, still almost 3 million lines of code, and the complexity is rather high. So we just made a calculation how many test cases we would need to get up to 80%, and that's much more. And I think Evelyn will have a good talk about that in her presentation. That's much more than you tend to write manually. It would be much more than 500,000 of test cases, so that we would end up with approximately 80%. And you see we are far off from the 80% right now. And anyway, maybe I shouldn't talk it, or I shouldn't confess it. That product is in production. And sort of everyone in Austria is using it to some extent. So, well, I don't say or don't recommend that 20% is enough or 26% is enough, but I will come to the conclusion on the last slide. If you're writing or creating or generating test cases, think about the kind of test cases, which is most important for you, where you have got to have some bulletproof classes or implementations or methods, and where you are rather sure that it will work or it is working, but you don't even have test cases for it. Sounds a bit stupid, but I think that's some sort of a realistic approach. I think all the other reports, so I'm skipping it just to give you an idea. If you have test cases, and the most important thing is how to come to these test cases, but then it's rather simple. If you integrate them into a continuous integration like Jenkins or whatever, you do have a lot of tools which, just as simple as it is, do some bytecode instrumentation, and they count and provide you with interesting reports with a lot of red and green and whatever kind of colors. It could be Jacoco, it could be Kubatura, it could be Emma. The same works also for COBOL, by the way, with other tools, of course, and so on and so on. So you always have something like a sort of summary report where you see is it packages now or going down to individual files, what has been covered and what has not been covered. The next step, I think you all know these pictures, is to find out which statements have been reached. That's a famous green background, and which statements have not been reached. And as simple as it is, you see here a hint that the branch is only partially covered, and this statement has not been reached because when you executed a test case, the parameter had not been smaller than 10, because else it would have been in, and so on and so on. So, yeah. So in executing your tests, which you have to write or have to generate, Evelyn will show us, you come up with coverage for lines or also for branches. And in determining how many test cases you need for each method, simple to see, you will have to draw or consider or calculate the so-called control flow graph of each method. And to find out the minimum number of test cases you need, you have to determine the complexity, or the McCabe cyclomatic complexity to be exact. I have a very, very bad example here, so I need a drink while you have a short look at it and find out, oh my God, why did it do it? So that's, I got to confess, that's a stupid, and by the way, also wrong implementation, but that's not so important, of finding out the number of days per month for a certain year. So how to test it? How many test cases do we need at least to find out, or how many equivalence test methods do we need to define? And so in analyzing it a bit, we come to a control flow graph where you see all the sort of branches in it. And if you count it, you will find out that there's the control flow graph and the complexity gives you the number of the different ways or different paths through the program coding. So if you count these different passes, you will find out that you need at least 6 test cases for a complete coverage of that control flow, or the algorithm shown before, to find out the number of days for a given month and a given year. But like mentioned, that's a minimum. The realistic approach also is to find these corner cases. Just consider a month, as simple as it is. Of course, a correct month for a valid date is only between 1 and 12. But always find out the test cases which are slightly out of that valid area. So the famous off by 1, by +1 or by -1. So also find out for test cases for the equivalence, it's too small or it's too big. And try to find out, because that's somehow, why is this famous off by 1 such a typical error? If you just think of if A is bigger than B, or A bigger and equal to B, or the negation, if A not bigger than B, and so on and so on, it's always dangerous that you miss the condition maybe just by 1. So that's the off by 1 testing approach, and thus you end up with more test cases than the minimum very soon. Or that's in German. Sorry for that. I didn't consider. So for the test cases, okay, I can skip that more or less, but you will find out categories for test cases where you define the expected result, and you of course test it against the actual result which is returned in the test case. Or in formulating these into equivalence test cases, you see that we are having now a couple of more than the minimum, because we are addressing the invalid months or invalid years also. So that's some sort of way how to find out the equivalence test cases. And I think Evelyn will show us later on that for some of these trivial methods or even more complicated methods, you can do it with tool assistance. So you don't need to write it manually, which is a tremendous effort saver, of course. So coming back to that correct implementation, I think you made up your mind maybe already. Is it a correct implementation? No, of course not. First of all, because of this 32, of course, which you have found out, of course. And in providing the test cases, you would have found out very easily. The other thing is, of course, there's such a lot of date-time handling around, in particular since Java 8, and Arlet would be able to tell you what's in Java 19 or whatever kind of Java version, and which is much easier than this, and so on and so on. Yeah, the message is for that implementation, don't do it this way. Even if you would have the interface return something like that, because that's, yeah, in the Java runtime, and it's easier to reuse than to reinvent the wheel. So more coming to some sort of previous conclusion. I alluded to 80% or 100%, of course, they are ideal. So to reach full code coverage, full statement, full branch coverage. I showed you that we just had 26%, and they had been sort of enough for a running project, for an important project. And that's something with citation from 1984, changed a bit, of course. So all classes are equal, but some are more equal than the others. So I'm using picks and classes, and I think you know the citation. There's something like these famous getter, setter, whatever data transfer object classes, which do sort of really nothing. I wouldn't tend to say don't write test cases for that. Yeah, I say do not write test cases for this, but use a tool to generate it. Because if you have a problem in these trivial DTO Java classes, then you must have a problem with the whole project indeed. So these should be generated and maybe not even considered. You can use this to very easily extend the percentage of your line coverage. But to be honest, you're sort of lying or cheating because, like I mentioned, if you have problems in the DTO Java classes, then you have other problems as well. So sort of have a look at the important classes. That's a trivial aspect maybe, which is important for you. That's some sort of utility classes, which many others use as subroutines or as features, or not even used inside of your project, but by other projects. Make it bulletproof then. So like an internal standard class for whatever, for billing, for printing, for creating PDFs, and so on and so on. Make it bulletproof. Try to go there up to 80, if not 100%. And then, of course, the famous business critical classes where you do some calculation and where you just cannot afford to miscalculate because, yeah, you will read your name next day in the newspaper and so on. And then also use statistics to see which are the classes which are used most often. And try to make them bulletproof as well. And that's also a good hint to have a look at performance if they are used a lot. And many times make them performant. So KPIs, I can't say go to 100%, but go to 100% for your important classes or 80%. Yeah. Thanks for your time.
Thank you very much, Reinhard. So there were two questions, actually one question, and then Evelyn, I think, answered it.
Maybe I'm stupid. If I look at the... Yeah. Not only the Schaltjahr was incorrect. So if that's been the question, yeah. I know there had been errors in it. It's always the famous excuse, I did it with intention. There also had been errors as far as the coding convention is concerned. So starting method with an uppercase letter and so on and so on. So it's a very bad implementation. I agree, I confess. But I think the Schaltjahr stuff is not the right algorithm from Gauss, also true. Yeah. And hopefully the appropriate test cases would find it out. So it's more an example for sort of black box testing, find out the stupid things I have implemented there in creating or writing, manually coding the test cases. And you should find at least 2 errors, at least. So thanks, yeah.
Okay, perfect, Reinhard. So as just we look on the time, I think if anybody has any other questions, please write them into the chat and we will get to them after.
Sure. So I stop my screen.
Yes, perfect.
Great.
It worked perfectly.
Oh.
You're done.